This coral reef restoration site is located in the Nusa Islands off the coast of Bali. The islands are a popular tourism area with many overnight tourists and day trippers from mainland Bali visiting the area for beach and water sports such as snorkeling and diving. The islands are also ecologically significant with high biodiversity of corals, fish, and other marine species. These healthy reefs are valuable both for preservation of marine biodiversity and for the tourism economy of the island. Unfortunately, over the last several years, the area along the northern coastline of the islands have been receiving many impacts. Changing shorelines with coastal development, increased boat traffic, careless tourism practices, and dragging fishing nets have left some areas of coral reef broken. When coral becomes broken, it forms vast flat rubble patches which erode and smother neighboring areas of healthy coral. Over the past decade, the Blue Corner Marine Research Team has been monitoring these sites. Several of these rubble patches keep expanding in size, larger and larger. Young coral recruits have little chance of survival in these rubble fields, which shift in the current and smother any attempt for young corals to settle. On the periphery of these fields, rubble erodes and breaks apart healthy coral stands and smothers healthy coral colonies. In order to develop an appropriate reef restoration plan for this area of Nusa Penida, we needed to determine what the reef in that area historically looked like, so that we could have a blueprint of what kind of reef we were trying to restore back to. This was done from looking at historical reef health monitoring data and photos of the area, analyzing the contents of rubble in terms of what species of dead coral skeletons existed, as well as doing surveys of adjacent healthy areas of reef along the same shoreline and depth. Part of recreating a reef is to look at what physical aspects are currently not allowing self-recovery of that reef. In the case of the Centel restoration site, the reef structure has been transformed from the shifting rubble, creating a lack of topographical complexity in the rubble fields. In order to restore reef structure, we needed to take active measures to stabilize the rubble, increase topography and habitat, and provide stable substrate for coral and other pioneering reef organisms to settle upon. The scale of the restoration site was mapped out so that we could determine which physical restoration measures to use and areas to focus restoration efforts. For structural restoration, we chose to use a variety of structures, however with a primary focus on coated rebar frames due to their ease of installation and cost-effectiveness. Frames are coated with epoxy and sand to prevent premature metal degradation and to promote coralline algae settlement and coral attachment. These modular structures can then be transported to Centel restoration site and installed by volunteers. Initial frames and structures were placed along the reef crest and other high erosion areas in an attempt to trap rubble from shifting down into healthy areas of reef. We put additional structures in close proximity to living areas of reef and in clusters, in order to promote animal corridors and fish utilization of patch reefs created by the structures. Over time, gaps between the frames have been filled in with coral growth, as well as with additional frames to promote diversity in size, species, and age. In addition to the coated metal frames, we've rolled out metal roofing mesh across areas of rubble in an attempt to stabilize rubble movement. We found that the mesh stabilized rubble for a long enough period of time for sponges and soft corals to settle and begin to naturally stabilize the area. This structural restoration step was added after we conducted a test plot of mesh over several months to track rubble movement and erosion. After the structural restoration step, it was time for biological restoration. In an attempt to stimulate recovery of biological aspects of the reef, we chose to increase habitat for fish and invertebrates by transplanting corals upon the structures. Suitable coral species for transplantation were defined by analysis of our target community. In other words, what we projected our mature reef community will look like in several years' time. We chose to focus on dominant species growing in adjacent areas at similar depths and environmental conditions, as well as some of the quick-growing habitat-forming species such as acroporas. Some of the dominant hard coral species in the area which we chose to use for transplantation were a few different species of acropora, Echinopora, Galaxia, Montipora, and Porites. We transplanted coral both in single species frames and mixed species frames in order to recreate heterogeneity of habitat. Corals were sourced from the adjacent area in order to preserve genetics and suitability to current environmental conditions of the area. As one of the means of coral reproduction is asexual fragmentation, we are able to take advantage of this for coral transplantation. The broken coral fragments were then prepared for transplanting by cutting to size and removing dead areas. Some of these coral fragments are taken to our rope nursery, which allows the fragments to grow under optimal conditions with good water movement and away from benthic predators. The nursery corals are grown out to larger sizes and then used as parent stock for our transplants. Having a comprehensive monitoring program is important to track recovery trajectory at the restoration site, to ensure that the site is recovering as anticipated, and if it is not, then to adjust our management and restoration efforts accordingly. Over time, as the site begins to be filled in and coral coverage increases, settlement of other organisms begins to take place. Fish and marine invertebrates begin to utilize the area. Regular monitoring is conducted on the site to look at transplant growth and survivorship, as well as secondary settlement of other marine organisms, fish utilization, and coral health. Coral growth at the site is tracked over time and mapped for increase in coverage.